if you can hear me, could someone just say something in the chat bar that we're broadcasting properly, just to avoid the problems from last time? Yeah, I see someone typing. Okay, cool. So, well, welcome to this next edition of Ask a 3D Designer. Again, I'm here. I'm Alex Greisen, the user experience designer here at Sculptio. This is Alvise. Introduce yourself.
Hello, everyone. I'm product designer at Sculptio. Hi, Alex.
Okay, cool. So, Alvise, product designer. And while we're waiting for 2 or 3 more people to join up, I'll just be talking about some of the events that we're going to be having in the next 4 to 6 weeks. Here in Paris, where our headquarters are, we have the Maker Faire in the first weekend of May. So we'll be there at the Maker Faire. So if anyone is in France at the time, do head on to the Maker Faire. I was there last year. It was a lot of fun, as was Sculptio. And yeah, no, it was a lot of fun. It was my first Maker Faire. So this will be my second. So I hope to see some people there. Also in London. So you still have plenty of time to look into that, get tickets. Again, we'll be there. We were there, actually the last 3D print show in London was the end of last year. So it was only about 6, 7, 8. But it's a great show, lots of people there. There was Adobe, there was Autodesk, everyone was there in the industry. So it's a great show as well to head along to. And again, we'll be there if you want to ask us any questions. And another little piece of information is, I don't know if it's been posted yet, but on the blog, you'll find a nice write-up about the Poppy robot. So the Poppy robot is a multi-piece robot where all the pieces have been 3D printed. Check that blog post for a lot more information. Now we have a few people online, so I think we'll get to what we're talking about this time. Last time we spoke about multi-shells, and we spoke about multicolor models and high polygon models. This time we got a few models from some of our listeners, from Samuel Clay and Pascal Verbeek. I hope I'm pronouncing the names correctly. If I'm not, do ping me in the chat. We'll be looking with Alvise at the first of these files, which is from Samuel Clay. It's a CAD file. Now, correct me if I'm wrong, Alvise. Samuel made sure that his model was manifold, but he found that it was still not 3D printable, and he wanted to know why. Could you bring us through Samuel's model and just explain what some of the issues could have been with his model? I mean, first of all, maybe starting off with what manifold means and why it's important before we see why his files work.
Sure. So if I've been able to share my screen correctly, you should have been watching my screen and my Sculptio account at the moment. I uploaded the file you were talking about, Samuel's Clay file. It looks to me exactly which the function of this part. It looks like a kind of electronic case.
Yeah, it looks like a kind of casing. Okay.
I think, sure, a plastic component of a product. So yes, as you said, the concept of this user was he had to produce a manifold file, and he said he succeeded in doing it, and he was asking for more advices and so on. So we took a look at it, and we did see a manifold model, but we found another problem actually in it, that very small one, and it's a multi-shell file. But let's talk about what first it means to be manifold for that 3D model. The mathematical description of manifold is quite complicated, but to make it easy, long story short, each edge of a printable mesh needs to be connected to 2 triangles, more, no level, and this means that all these amount of triangle that compose the mesh, it's closed, or as someone says, it's watertight. There are no holes. It's connected. That's pretty simple. So this user succeeded in creating this, and what it didn't succeed in is creating a single shell model. So how can be this both manifold and multi-shell? So this model is composed by, I think, around 20 shells. Each shell represents a part that is manifold itself, but it's intersecting other manifold parts. So even if the model is the sum of many, it's not correct. These intersections are not good for 3D printing. We have been talking about multi-shell objects already in the past 2 webinars. And so now we have another case here, and we can show you similarly to the previous 2 ones. So first, take a look in the website to the cutaway view, identify these shells, and see how this multi-shell file looks like once again. So, for example, here you can clearly see this snap that is intersecting the base of the part, and in the same way, if I cut away in another way, I can see that the same thing, that kind of cylinders that are on the corners of the part.
Okay, so just to
Here.
summarize here, Alvise, what we're talking about is Samuel gave us a model. Okay. Yeah, so Samuel gave us a model, and he wanted to make sure that the model was manifold, which means watertight, which means that we know it's a single object and a complete volume, and that we can 3D print that. But it was still refused for 3D printing, and what we can see here with the online cutaway tool is that the reason it would have been refused is even though it's manifold, we have many intersecting volumes, and that's causing a shape which is impossible to 3D print. And that's why it was refused, and that's what we need to fix now.
Yes. So the way we will fix this, it's similar to the previous webinar, the previous 2 webinars actually, but modeling file, as you said, he has been modeling this part in rhinoceros. So he kindly gave us a modeling file, exactly is a step file. So what use this modeling file to fix the multi-shell problem? I that every time you have access to the original source file of a model, you have way more control of the part and any other privileges that you don't have in mesh modification software like MeshLab or Meshmixer, as we showed in the last webinars. So I'm going to put it bottom. This is Inventor. This is the CAD software that for this operation. Step is a good format for exchanging CAD files. It works in every CAD software like SolidWorks, Rhino, Pro Engineering or whatever. So the steps that I'm gonna show you now to correctly model this part for be replicated in any of the CAD software available, any CAD software that you have. They are really similar features, and the names of the functions might differ a little bit, but essentially you will see exactly the same kind of workflow that I'm going to show you now. So this is how the step file looks like. On the stuck on your left, you can see 9 parts. We are treating them as bodies. Is how.
Okay, so Alvise, sorry, you cut out there. Could you just repeat what you said there about just before you started talking about 9 bodies? Could you repeat that?
Yes. So the editor showcase is a step file. Step file in Inventor, it becomes assembly file. So an assembly is how Inventor calls. So every shell of the model that we had is here treated as a different part. And there are these 9 parts on the left. First thing I want to do is to check how these parts fit together. To do this, I need a cut wheel to see inside the model. So the way to modify part in Inventor when I'm in this assembly environment is to the only way is to enter in the part. I don't have I can't modify parts when I'm in this environment. To enter first part, main body of the object, and I will double click on its name on the left, and as you can see, the stack is open, and I'm now able to modify only this part. For a cutaway view, I need the inspect and section feature. Plane that I want to use as a cutting tool and move it where in this case here, and click on apply. I'm now watching inside. So in this first part, I have these cylinders that are not exactly intersecting the main body of the object. And in order to, I first want them to as as before. So um, I'm going to proceed in this way. Open the bodies stack, all the bodies that belongs to this object, and I want to hide the main one so that I can proceed to cut these cylinders. As you can see now, I can select them separately. This means that if I want to operation and that is the same on each of these cylinders, I have to repeat, avoid this. I'm gonna merge them in a single body so that I will have to do this operation just once. So to merge bodies, I use the combine tool, select first a base and then a tool body. The tool body are all the other bodies that I want to merge with the first one. So the purple is the base, blues are the tool bodies. Join and apply. Now, as you can see, I can select all of them together. Next operation I want to as they are irregular. It will not be a clean operation at all. I want to create a flat base first and then extrude them to reach the main body. So I want to cut these 4 cylinders with a planar cut. I tried to create a plane to use as a tool for cutting. So offset from plane, the horizontal plane, and bring it. Just be sure it's where I want it to be exactly. And then split tool. I will select the third option. So split solid. That's what I want to do. First, select the split tool. It's the plane that I just created. And secondly, the solid that I want to split. That is this all the 4 cylinders that I just merged. So apply to see it's shaded with edges. So now I can see a line. This means that I cut this 4 cylinder. I want to delete the bottom part. So modify, delete faces, and select lamp or void in order to be able to all this bottom part and click OK. Delete them. Appear the main body. So now I have a clean area to extrude and to merge with the second one. In order to extrude those faces of those cylinders, I first need to create a sketch to be used as a base. So as a sketch plane, I use the same plane they created before. I'm going to slice traffic to find those lines that I want to be the base of my extrusion, and project cut edges. Select the plane. Those yellow lines are now the cutting edges that I want to use. If you finish sketch, I'm going to use now the extrude button and select the inside area, the closed loop that I just created. So I now have 4 cylinders. I don't want them to be extruded. I'm going to use the extend option and select 2. It means that I need now to select another surface to be set as limit of the extrusion. So I select the bottom surface of this concave part, and as you can
Sorry, Alvise, you've cut out for me, but I'll just sum up here quickly. So what we had was these multi-shell objects, and what you're doing is you're going to be using the lower surface to cut these so that we can make them both.
yeah. So I've now recreated this part correctly, and the perfect moment for a Boolean operation. It's in Inventor is called combine. I simply, as I did before, I used the main body as a base, the second as a tool body, and I have this star here that is also an intersecting body. So I used the tool body as well. Then on the back here, I know that I have more bodies because kind of the logo. This logo is been drawn on the back, and it's kind of extruded from the back. Yes. So I'm gonna merge all of this stuff together, and yes, now I have one whole body. The stars is being merged, all the cylinders. Perfect. So I
So,
can
Alvise,
close
last time we
this
saw that a
editing
Boolean operation in Meshmixer we could only do with
assembly
two
mode.
objects. We could do that union. But it seems that you did with a lot of objects. Is that something that we can do in Inventor?
Files. I know Inventor. I don't know how to do that in SolidWorks or Pro Engineering or other solid modelers. Inventor allows you to pick as much elements as you want. So you pick a base and then
Okay.
infinite number of tool bodies to merge. So yes, that's pretty handy. So I'm back in the assembly mode. As you have seen, I now have a correct main body, cylinders and the star and the log in the back. Last thing I need to do is merge these green elements that are repeating on the edge of the main part. To do this, since they are already fitting perfectly each other, they just need to be merged to the main body. I will use um, I will use a feature that Inventor allows. You can find this in the Simplify tab, and it's a feature that you can only find when you are in the assembly mode, and it's meant exactly for this purpose, to merge different parts together in a single object. The assembly must be saved before performing this operation. So I save all my parts, click OK, and go back again to the Create Simplified Part function. In a new opening, in the moment I select this function, it's asking me to have a combination. There are three different types of styles, so it's basically a Boolean operation. It's a merge, there's intersect and subtract. So no, sorry, and separate. I'm gonna merge all this part together. This is exactly what I want to do. And click OK. A new part has been created. And as you can see, if you remember, there were colors on the model, like some part were gray, some part were gray. When I'm performing this Boolean operation, these colors are like merging, and the software is randomly more or less deciding which one to keep. So, for example, this part here stayed green. Gray. If you want to keep colors on your model, it's always better to perform all the Boolean operation or the editing operation on the geometry, and only at the end apply colors to the faces of the surface of your model, in order to be sure that they will not be lost or changed.
Okay, so Alvise, you would say that this model, now we've fused it together, we can
Right.
upload it like this to Sculpteo, and it should be printable now, right?
I've got the result that you wanted. You can see here on the stack on the left, option in print, and then 3D print preview. New environment pop-ups. Here you can see that the model is been meshed, and you have some information about the mesh on the top of the viewer, number of phase 55,000, and file size here. You can decrease or increase the quality of the model or faces by tapping options. In this window you have a couple of parameters to tweak. For example, if I reduce the maximum edge length to width as well as file size, so this depends on the quality you want to.
Okay, so Alvise, just to cut through you there, started off with a CAD file, okay? So we started off the CAD file from Samuel Clay. Sorry, so we started off with this, a model from Samuel Clay.
Yes.
His model was manifold, but it was multi-shell. And what we've just done is we've turned it into a single shell, and that should resolve all of the remaining problems for this file. It should now be printable. Now, we might need to stop there for this model because we're at 25 minutes, and I'd like to look at the next subject. We have a 3D scan from Pascal Verbeke. I hope I'm pronouncing your name correctly. And so this is a 3D scan of a head, right?
Yes.
And it needs fixing. Could you tell us a little bit about this 3D scan? Yeah, we'll just open it up. So just to explain, so Pascal is another customer who sent us this file.
Okay.
Okay, so here we see the scan here. Okay, so we can see your screen now, Alvise. We can see there's a hole in the head here. We'll need to be able to fix that and also maybe create a base.
Okay. Yeah, can you hear me correctly now?
Yep, that's fine. So tell us about this scan.
Okay, so we are in Meshmixer. This is a scan that the user gave us, and want you to get a great and easy to use software. So the result is pretty good, as you can see, but it's still printable mesh, and that's the advice that our user Pascal is asking for, how to make this printable. As you can see, when you open this Meshmixer, we already been talking about the software. It's free and easy to use and very useful for this kind of purposes. We just opened this OPJ file with texture, and we can see that the blue lines are defining two big holes in the mesh. We want to basically close these holes. There are not very simple holes because they're big, and then requires the user to actually create new geometry. They have to be a bit differently from normal holes. So let's first try to close the whole set of this person upward a bit. We want to delete and avoid this error. So the right tool to use in this case, it's selection first. There are two types of selection: Meshmixer, the brush, and the lasso. The correct one for this purpose is definitely the brush. I can adjust the size where I want. So the tool that I'm gonna use solve is
Okay, so Alvise is selecting the lip of this hole, and he'll now be able to close it up.
so I'm defining all the areas that look like strange on the head. I want them to be deleted. All right. And the tool is edit and erase and fill in the selection tab. So as you can see, all the orange triangles that I've selected before have been deleted and substituted with this new geometry that is now covering all the hole. In the top left, I have some parameters. I would suggest you first to press on W on the keyboard so that you will be able to see the edges of the triangles. First thing I want to do is to make all the triangles, all the new triangles as big as the triangles around them so that the model will look uniform. To do this, I will tweak the parameter refine and done until I visually think it worked. Be a bit smaller, too big. So we'll bring down the scale value. Here, I can play around with this bridge one. It's very useful. Smooth. It tries to create tangency in the edges, so I will keep it high in this case. So yeah, the shape looks good now. I'll click on accept, and the modification has been updated on the model. And as you can see, also the colors of the textures have been reported on the new geometry. So pay attention that on the new model, there will be a new image file that represents the texture that has been applied in this new geometry, and also this new image file has to be included in the zipped file you will be uploading in the website or opening in another software or whatever bring this model. So this, let's now go to the main problem of this mesh. Same technique to close this part, but tweaking it in a bit different way. I will try to create new geometry on the back, all this part here, in order to make a planar cut later and have a flat base in the model. I will be probably able to do it now, but I will be forced to do it on the neck. Then I would need to cut all the shirt back what I want. So again, try a bit bigger and I'm selecting all the areas on the edge. As you can imagine, the scale parameter will be kept higher in this case to create a bolder part. Okay, now we're good. Edit, erase and fill. Big, lower the scale, the verge as well. W again, showcase the edges of the model. Okay, I think we are right with this step. Click on Accept. Have been updated and return on the new geometry. So I don't. The base is still not flat. It's the last step we will do to make this model perfect. Edit and plane cut. The area that we're gonna produce is exactly flat, so that the bus can stand on a table, for example. Let's place the trap here. Click on Accept. Then we do it again. Okay, this area has been correctly filled. And if I now go to Analysis and Explode, check the printability of the model, I see no problem highlighted on the model. The
Okay, so Pascal
I'm now
looks
able
printable
to
now.
export this model, OBJ format, to keep. Yes. Able to model in an OBJ format, keep the new textures. We call it mesh fix. And it's good to see how this model this file looks like. Mesh fixed. You can see there is a new folder that it's the hole that we've been filling, and we have to
Hang on, that I didn't see.
Include this new text in the new file. So that file, let's go to this view. Mesh fixed, OBJ, texture files. Zip them together in a single folder, and that's what we want to put on the website. Okay, the file is 1.5 MB. It's gonna take around 1 minute. If you agree, we can skip this part. I already uploaded before the webinar started, so we can take a clear look to the result of this second fixing. As you can see, all the colors and textures
we might need to scale that up a bit.
You are in Sculptel, and I'm now able to order at this size. Meter high is just €8. I want if I wanted, for example, 10 centimeter, I can just scale it directly in the website, and all the prices will update. So no need to take too much care of scale in the softwares. You can do that in Sculptel. And also, if you think, I don't know, if you want it cheaper or yes, to fit a particular size, you can always do it directly online. So I've scaled it to 10 centimeters. It became a bit more expensive, way more expensive. And heroes. Let's take a look at it inside. And the cutaway view looks totally cool. What I can try to do now, since I increase the scale in this model, I can try to increase this new price by deleting material, unwanted material inside the model. So we have a specific tool for this. You can find it in the optimize tab, and it's called hollowing tool, and it inside the model. A second powder, otherwise.
Okay, so the model has been hollowed, and now we're just going to add 2 holes that have been automatically sized so that we can remove material that hasn't been used.
Created hollow part. Yes, the website is asking me to create, and you will.
Okay, I've lost you, Alvise. But yeah, so we've followed the model now. We've accepted the hollowing, and we've saved 35% on the price of the model. And if we scale it now again, if we reduce that to say 80 millimeters, we're automatically going to recalculate all of that hollowing and the size of those holes, so that price will automatically update.
So the Halloween tool finished well. It was pretty quick, as you can see, and with simple execution, we saved 35 euros, and I'm showing you now how the model looks inside. It's now in. So yeah, we are now, if we want to, we can now add it to the cart and take a look to the solidity check. It's now appearing on the screen. This looks, and then add it to the basket and order.
Okay, great.
And receive it at home.
So I might just sum up now. So we've just seen Pascal Verbeek's scan. Now Pascal had done the scan and needed it fixed because it was basically just a wrapper. It was like a shell that had no volume. And what we did was we imported it into Meshmixer. We then were able to clean up the file by filling up those holes. We were able to smooth that out, make a base by making a planar cut. And then by hollowing it on Sculptio, we were able to save a lot of money on actually making that printable. We were able to hollow out any unused material which is inside. We were able to save on that 3D print. And that took, I think, 10, 15 minutes maybe, was how long it took you to fix up that model. Naturally, with a bit more time in Meshmixer, we could clean up the colors on the back and have a nice model with a good solid base. But for 10 or 15 minutes work, I think we were able to do a lot in a very short time. The first model we looked at was from sample clay. So it was a kind of, basically what sample gave us was what looked like a casing for some kind of product, some kind of electronics product or others, which was manifold. So it was a closed shell, but the problem was it was many closed shells which were intersecting, and that made it unprintable. So what we were able to do was, by importing into Inventor or any other CAD program, we could also have used things like the step file. We could have used Rhino, which was the original CAD software. We were then able to use Boolean operations to be able to merge those parts in order to create a single shell model, which was also manifold, and we were able to print that then. Now, I'm just going to close up now because we're coming up to 45 minutes. While I'm closing up, if there are any questions, please do ask them in the chat. It's on the lower left. In the meantime, while I'm waiting for any questions, I do invite you to send your files like Samuel and Pascal did. As you can see, in a very short time, we can fix up a lot of these very common issues which can come up when you want to turn something virtual into something real. Or we can give you a few tips on your models. If you just send them to ask3d@sculpteo.com, we'll have that email in the description of this video. It's also, that's all on the website as well, sculpteo.com. So you can send us those models and we'll pick one or two every week to be able to show you how to make that 3D. I don't see any questions coming up. So I'd just like to thank, well, first of all, Samuel and Pascal for sending in their models. I'd like to thank you, Alvise. Pascal is typing a question now, I believe. I'd like to thank you, Alvise, for showing us how to do all of that so quickly. I'll just let Pascal finish his question.
Thank you, Alex.
Oh, cool. So Pascal's congratulating me on the great job. Yeah, it's been a great pleasure. And yeah, so I'm sorry if there were any connection problems. I had a few connection problems. We'll try to solve those for the next week. And again, happy 3D printing and see you next week. So goodbye, Pascal, goodbye, Samuel, and everyone else. And have a great week. Bye. Oh, sorry, I'll just let Pascal finish. Yes, so Pascal's question is it possible to have a recording of the past webinars? And yes, all of our webinars are put up on YouTube a day or so after we've done the webinar. So you will see this webinar will be posted, I think probably tomorrow on our YouTube channel. So just look for Sculpteo on YouTube and you'll find us. And in the same channel, you'll find all of our past webinars, which deal with a lot of the same problems where we're talking about multi-shells, we're talking about filling up holes, fixing geometry, fixing colors, and things like that. So thank you, Pascal, and thanks for the question. And again, I'll close with happy 3D printing. Bye-bye.